So this is just a quick concept bite on how a UV vis works. So this is just our electromagnetic spectrum, and if you just check out the UV visible area, you notice that it corresponds to valence and bonding electrons. So it's specifically these transitions that I'm looking at. So this is N to pi star transitions. So this is the one on my my left here. These are my lowest energy valence transitions, and pi to pi star transitions, which are next highest. Sigma to sigma star usually can't be observed using UV vis. They're too high energy. They are well into the UV region, certainly below 200 nanometers. And your common UV vises will only be able to record spectra from about 190 to 900 nanometers. So the basic workings of a UV vis consist of our 5 types of kind of components of a spectrometer: the source, the wavelength selector, the sample holder, the detector, and the sample processing. In this case, my source is usually either a xenon or a deuterium arc lamp. Most instruments come with both. Now, specifically when we're looking at UV wavelengths, so 200 to 400 nanometers, we use the deuterium lamp. Then we usually swap to the xenon lamp to look at the visible part of the spectrum, 400 to 800, 900 nanometers. The reason being the xenon lamp just doesn't have the intensity down in the UV region, whereas that deuterium lamp does. We then have to select our wavelength. We don't want to pass all wavelengths of light through our sample, so we select the specific wavelength. This gets done using a scanning monochromator. So our scanning monochromator is able to rotate to select through the different wavelengths. Now, it's a little bit more complicated than that because I usually have to have some sort of optics between the lamp and the monochromator, specifically usually to select between which lamp sources I'm using, but the basic principle is there. Once my wavelength is selected, I can pass it through my sample, and here I have a sketch of a typical dual beam instrument. In other words, I'm passing it through a blank and my sample at the same time. Now, I know that in the labs you've maybe used water as a blank if you've used a dual beam instrument, but it's perfectly fine and actually normal for a spectroscopist to just use air. So I just need to put my sample in one side. So what the blank is telling me is it's telling me any variation in the intensity of the light source, of the light that is being generated. And so I can normalize my absorption based on that. So this beam splitter is just a piece of optics which will let half of my light pass through and the other half will be reflected down a separate path. Sample holders can depend upon what I'm measuring, but if I'm measuring in the UV, I have to use quartz. Quartz is clear all the way down to about 180 nanometers. And so is not absorbing my sample. If I try to use a plastic cuvette in the UV, I just see total absorption of the light because the plastic absorbs the light at that wavelength. So after the light has passed through my sample, it goes to a signal detector. Nowadays, most signal detectors tend to be CCD based. They very, very rarely are PMT. It's very unusual to see a PMT in UV vis spectroscopy. So we collect the signal from both the blank line and the sample line, and that gets processed. So it's going to deduct the blank from the signal so we know exactly what the absorption due to our sample is, but it also will do some analysis because almost certainly you've set in a baseline, and this baseline is a cuvette holding your blank solvent. So if you're recording your spectra in methanol, you'll have recorded that same cuvette with methanol inside it, just as your baseline. And the signal processor is removing that signal from whatever signal you're now recording. as well as comparing it to what's happening on that second line. So even in a very simple instrument like a UV-Vis spectrometer, there's quite a lot going on in the signal processing step that you don't have to think about. Hope this gives you a little bit of help in understanding how the inside of a UV-Vis works. I'll be back with more.